Welcome to solverfy.
So now we'll work on problem 70 from chapter 17. In this problem, we're given two parts. In the first part, we're asked, will cobalt hydroxide precipitate from solution if the pH of a 0.02 molar solution of cobalt nitrate is adjusted to 8.5? So here, to know if precipitation will occur, we need to calculate Q. So we can go ahead and write the expression for the equilibrium of cobalt hydroxide in solution. So we have cobalt 2 plus 2 hydroxide anions. And to know the initial concentration of cobalt, we're told is 0.02 from the cobalt nitrate. The concentration of hydroxide we can find from the pH, which we're told is 8.5. And pOH then would be equal to 5.5. And concentration of OH would then be equal to 3.16 times 10 to the minus 6. So that's our initial concentration of hydroxide. So now we calculate Q. We don't need to know the equilibrium. We just need to use these initial concentrations to calculate Q, which we can do by multiplying 0.02 times 3.16 times 10 to the minus 6 squared. And that gives us a value of 2 times 10 to the minus 13. Now, the KSP for cobalt hydroxide is equal to, from Appendix D, 1.3 times 10 to the minus 15. So we can say that Q is greater than KSP. So we will experience precipitation. So in part B of this problem, we're asked, will silver iodate precipitate when 20 milliliters of 0.01 molar silver iodate is mixed with 10 milliliters of 0.015 molar sodium iodate? And we're told the KSP value, which is 3.1 times 10 to the minus 8. So first we need to calculate the moles of iodate. So we have iodate coming from two sources. So we multiply the concentration of both times the volume of the solution. For both solutions, so we can get the total moles. And that value is equal to 3.5 times 10 to the minus 4. And so then we need to find the concentration of iodate, which is 3.5 times 10 to the minus 4 moles, divided by the total volume, which is 30 milliliters or 0.03 liters. And that gives us a value of 1.17 times 10 to the minus 2 molar. The concentration of silver ion, it's just a dilution in this case, so we multiply 0.01, which is the initial concentration, times the initial volume to get moles, and then divide by the volume to get concentration, which is now 6.67 times 10 to the minus 3 molar. So then to calculate Q, which we can do here, Q is equal to 3.5 times 10 to the minus 4 times 6.67 times 10 to the minus 3. Since it's a 1-to-1 ratio of the ions, we don't have to do any exponents. And this value is equal to 2.33 times 10 to the minus 6. And we see that the value of KSP is 10 to the minus 8. So once again, Q is greater than K. So we will experience precipitation once more.